Experiment 2 Part B. In this experiment, you're going to design and conduct your own experiment based on your findings from last week's lab. You're going to apply standard error bars to a figure. You're going to practice scientific communication, which includes describing and explaining data, something that students have difficulty with, so you want to focus on that. And students will read an example of a scientific paper in a peer-reviewed journal. So last week you did a basic experiment looking at the influence of ethanol on cell membrane damage as measured by the leaking of beta-cyanin. This week you're going to design a further experiment. And in order to do that, you want to look at your data from last week. So for example, if your data climbed greatly, or did nothing, or dove, or whatever the data may have done over the course of various ethanol concentrations, you'll want to design a new experiment to answer a question. So for example, let's say that our data was unchanged, then climbed, then plateaued. There we go. So I may have a new question about what was happening over a specific area of the graph. Let's say this area of the graph interests me. Let's say this area of the graph represents, I don't know, 5%, and over here is 10% ethanol. So I might design a new experiment to look at this area in more detail, and I may test 5, 6, 7, 8, 9, and 10% ethanol to look at that very specific part of the graph more specifically. So I may analyze that region of data and get a clearer picture of how cell membranes are affected. I may notice that there is perhaps a tolerance in beet cell membranes to low levels of ethanol, but then at some point that membrane starts to fail, and I'd like to know exactly when it starts to fail, and if failure happens slowly, if failure happens quickly, and to do that I would zoom in on that piece of data. You may have other questions or different looking data, and you'll want to look at some other aspect of cell membrane damage on beets. And so you'll want to design your own experiment based on your findings from last week. So you're going to plan a new experiment. You're going to write down as well as draw a hypothesis. Be sure to include a rationale. So what we mean by that is, first of all, it's usually easier to start by drawing. So let's say you are going to zoom in on the data and you're going to test between 5 and 10%. I'll put a percent sign here. I'm not going to label the axes fully here for simplicity's sake, but between 5 and 10% ethanol. So this is ethanol concentration. All right, and then over here is beta-cyanin concentration. So how much beta-cyanin has leaked out? And our units are micromoles. Okay, so let's say we predict that, based on last week's data, that maybe we think 5% will not damage cell membranes, but maybe right around 6% we predict a gradual increase in cell membrane damage. You may predict that it spikes straight up. It depends on what you think is happening. You don't want to make this up. You want to base it on reason and logic. So that is the graph of a hypothesis. It's just a sketch, a quick sketch of what the data will do. You also want to write your hypothesis. So you might write if ethanol concentrations increase beyond 5%, then cell membrane damage will occur. And now we say include a rationale. A rationale is why you make that prediction, using your knowledge of science, not making stuff up, but your knowledge of science to present a reason for your hypothesis. So my hypothesis might be something along the lines as ethanol concentration increases, above 5%, cell membrane damage, forgive my writing on this thing, damage will increase as well. All right, something like that. Then that would be the end of it. But the rationale would be, instead of ending this sentence here, you might be putting in a because. Why is that prediction what it is? So instead of ending the sentence, we might continue that sentence because as ethanol concentrations increase beyond 5%, which beets seem to be tolerant to, then proteins will be denatured. Membrane proteins will be natured, increasing leakage above 5%. So the rationale is the because, or the reason why. You can do this by putting in a because after your hypothesis. I predict that as this happens, then this will happen because, and you always want to have a good rationale behind your predictions. It's not science if you just make stuff up. You're not just doing this to see what will happen. You're testing a hypothesis, a hypothesis that is based on something real, your rationale. So your because is very important. Very important. Okay. Another thing you want to be ready for at the beginning of this week's lab is a quiz. So watch this video as well as read the beginnings of your lab manual, the pre-lab quizzes, for example. So look at the pre-lab quiz in the manual. Look over the experiment that you did last week and the equipment that you used. Look over the equipment for this week's lab. Look over the basic procedures in this week's lab. What are you measuring? What units are being used? What is actually happening in this experiment? What calculations are we doing this week, or calculations that we use every week? Always be ready for a mass balance equation. And know what goes into a figure. You may be asked to draw a figure or complete a figure or analyze a figure on your quiz. So be ready for that and have a good lab this week.